Welcome everyone to our free monthly webinar. This month we're going to talk about the risk behind missing arc flash labels. So for those of you who are repeat attendees, thanks so much for joining today. And for those of you who are new, please take a moment and get familiar with GoToWebinar and find that question feature or the chat box, because that's how you're going to be able to interact with me today. Any questions, comments, concerns, stories, or jokes, as I like to say, please feel free to share them. We do have all of our previous webinars recorded and posted on our YouTube channel. So you can go to YouTube and look up the free electrical safety trainings playlist and watch all our previous free trainings there as well. Or you can just download the handout. The PDF of today's slides are in the handout for GoToWebinar tab, section, button, icon, however it shows up for you. You can download that and then just click on the link, as well as keep this information for future reference. So for today's training, we're going to talk about arc flash labeling requirements, what it actually is required, the consequences of missing labels, what could that lead to, how do you make sure that your labels are compliant, and what are those solutions for getting labeling done properly. And then of course, for whatever leftover time we have, we'll open it up for questions and discussion. So a lot of good information that I think we'll cover today. First up, I'm going to open a polling question. So it should just be pretty simple. You select your answer and click the submit button. So do you have compliant arc flash hazard labels applied to your electrical enclosures? So the poll should be open now. You should say yes, no, partially. In other words, it's not completed, only in some equipment, or it's outdated, or you're just simply not sure. So do you have compliant arc flash hazard labels applied to your electrical enclosures? Go ahead and submit your responses here. I see several people already jumped on that. Got about half of you voted so far. Give it just another few seconds before we close this out. Okay, I'll share the results. So it looks like most of you do have arc flash labels and you feel like they are compliant, and then there's a little bit of a mix for the other options. So that's fantastic. I will say, even if you're not sure or you don't think you have that completed yet, that's okay. It's not, hopefully not going to be too daunting to complete, and there are many options to do so. So let's talk about what actually is required, and then we'll get into the whys, what would happen if you don't have them. When it comes to, let me double check that my screen's still sharing, very good. When it comes to the electrical safety regulations, we have, of course, OSHA. So 1910 subpart S and 1926 subpart K for your general industry and construction industry. So OSHA looks to codes and standards, mainly from the NFPA, for how to comply with those requirements. So when we look at OSHA regulations, frankly, a lot of them are pretty outdated. And then you get to the NFPA standards, and they are updated every 3 years for the electrical codes and standards, right? Well, so let's take a look at what codes and standards apply for arc flash. Well, but wait a minute. Did you know, breaking news, the National Electrical Code has the latest edition available. The 2026 edition is available for purchase and/or free access online. So it's time to get up to speed with that one. If you go to the NFPA website, the current edition is the 2026 version, and it has a nice little summary about the types of things that were added or changed. A lot of it is just reorganizing to the style manual that they are putting into effect, but please note that as of September, this past September 2025, it is effective and supersedes all previous editions. Now, why do I mention this? Why am I making a big highlight about that? First of all, it's just exciting because, getting a new code book is like Christmas morning for us electrical nerds out here, but also because of a big change in the 2026 verbiage. Now, before I get into this, I just want to specify that the National Electrical Code has always, at least since I started my career, not always, but has for many years, required arc flash labeling, arc flash hazard marking. Now they've gotten a lot more specific on how it's worded because people frankly were trying to find loopholes. They were reading it and trying to figure out, well, how can I do the minimum requirements without actually following the industry standards, such and so forth. And so there were these generic labels that said, warning, arc flash hazards present, follow industry best practices, blah, blah, blah. But no specific information, no actual way to protect themselves or others. Well, the NEC committee, the National Electrical Code, the 2026 edition said, enough of that. We are going to get specific with this. So in 110.16, it has been overhauled. The arc flash hazard marking is not just some generic label indicated, but it's actually going to follow industry best practices, or applicable standards, I should say, such as the NFPA 70E. So as you look through this, you'll notice actually a lot of this verbiage is very similar to what the NFPA 70E has been saying for years, okay? Again, they're just clarifying this was what it was always meant to be. You don't want to just put a generic label. You want something that actually will tell qualified persons what that arc flash hazard boundary is, what the nominal system voltage is, and how to protect themselves, what PPE is required, or the incident energy level that they're going to be facing. One piece of information that is very specific here that wasn't necessarily included previously was the date that the assessment was completed. Now, this is important because, as we know, arc flash studies need to be reviewed at a minimum of every 5 years, and there's other reasons that that date is helpful as well, but now it is required. So there you go. There's your update. There's the breaking news. The 2026 National Electrical Code took out the potential for those silly little loopholes. No more generic labels. We need to get specific about what hazards are actually there so that workers can really protect themselves and others instead of just saying, be safe, be careful. That's not enough. We need to know specifics. I digress. So there's actually 3 codes and standards from the NFPA 70E, or NFPA codes and standards, right? So we've got the 70, the National Electrical Code for installation requirements. We've got the 70B for reliability and safety requirements, so the standard for electrical equipment maintenance, which I will say also points out the need for arc flash studies. And we've got the NFPA 70E, which is the consensus standard for electrical safety. Again, the National Electrical Code, the NEC 2026 edition, does still, it did previously as well, directly reference the NFPA 70E for how to get those arc flash hazard markings completed, how to create those labels. Okay, so that's what we're going to focus on now. Of course, there are the 3 main electrical hazards in the 70E that we need to address. The arc flash, arc blast kind of go hand in hand, and then we've got the electric shock hazard. But for the arc flash risk assessment, again, you notice a lot of this is overlapped with the NEC 2026 edition that we now have. So equipment such as panel boards, switchboards, control panels, meter socket and control, basically anything likely to require examination, adjustment, servicing, or maintenance while energized shall be marked with a label containing the voltage and the boundary and how people are to protect themselves when within the boundaries. And again, that arc flash study needs to be updated every 5 years at a minimum. If the data identifies a change that renders the label inaccurate, then the label needs to be updated or replaced. Now, this is a minimum. You also need to have your studies updated if there's new installations or system modifications. Ideally, have an annual data verification, but that is required for generation and transmission industries. If there's a change in the utility source, or if you've changed the configuration, the loading, or the impedance of your system, all that goes into the calculations, all of it. So every 5 years is a bare minimum update requirement for your arc flash studies. Okay, so that's what's required. That's the labeling requirements per the NFPA codes and standards. So what happens if you miss those labels? What happens if you don't apply them? Well, whether there's a label or not, of course there's the potential for an arc flash, frankly. A label's not stopping an arc flash from happening if it's going to happen. What it does is helps provide you the information for the severity how far out it can hurt people, and how to protect yourself when you're interacting with that equipment. Because otherwise you're exposed to blinding light and pressure and sound waves and molten material or vaporized material, even fragments or projectiles. The NFPA 70E calls it shrapnel, but just pieces of metal and plastic that are flinging out at you in incredible amounts of heat. So if you're not prepared, because you don't even know what the hazard level is, it could be the last thing you ever see. So, what are these consequences? If there are not compliant arc flash labels, the workers may not even realize that arc flash hazards are present. If there's not that indication to remind people, or at least notify them, maybe even initially, that there's a potential for an arc flash hazard, it may not even be on their radar. I still go to facilities, and my training or audit or whatever it is that I'm there for is the first time that a worker has ever heard of arc flash. I still have that to this day, believe it or not. It happens, okay? So workers may not even realize what it is that they're facing, that there's a hazard present, or they're gonna be left to making assumptions or guessing what PPE they should wear. And, we don't want to use the word assume whenever it comes to someone's safety. So the more specific, the better. Hazard boundaries could also end up being greater than anticipated. A lot of times people say, put up that 42-inch boundary or make it a 5-foot boundary. It's just, as a standard, we put 5 feet minimum, blah, blah, blah. Well, what if the arc flash boundary is further than that? Anyone walking by or in the area could be unknowingly exposed to those arc flash hazards if you don't have a label telling you otherwise. Another issue might be that workers simply forget or disregard PPE altogether. A lot of times I hear things about people saying, oh yeah, I know there's an arc flash potential in 3-phase systems, and I look for the labels. Well, but what if there's no label? Must mean I don't need PPE, because the pieces of equipment that require PPE have a label on it. Well, is that true? Are you sure about that? Are you sure that one didn't just get missed? Are you sure that it didn't fall off? Well, these are the kind of questions and exercises you can go through with your qualified workers in training, but don't leave that open. Take out this potential for guessing and assumptions. Put the label in place, verify that they're still there, and make it easier for workers to figure out, I do need PPE, and here's how much, and here's where the boundary is. So what happens if you don't? What if people walk up and they're working on equipment, or just opening it up to visually inspect it, or do infrared scans? A lot of people doing infrared scans nowadays. Maybe not everyone who should be, but they happen, and they're just wearing normal streetwear. Typical clothing, polycotton blend, synthetic fibers, even natural fibers, because they're pretty thin. What would that look like if they were exposed to an arc flash? Well, let's watch an example of an arc flash where a mannequin is in front of exposed conductors and circuit parts wearing synthetic clothing, which is, frankly, what the majority of people wear on a daily basis, unless they know otherwise.
This is polyester cotton clothing, a non-70E compliant mannequin in a Category 2R. As you can see, the consequences of this mistake are catastrophic. The garment is fully involved immediately, melting and dripping and shedding chunks. And look at how rapidly the back is fully involved. The entire garment, including the back where the arc never hit, is on fire. Our close-up front and side views will show the same thing in a little bit more graphic and close-up detail. This is not a situation that anybody ever wants to face. This is the consequences of wearing fuel rather than arc-rated clothing into an arc. We take a look at the slow motion. See exactly what's happening. The arc pulses, and as it fades, you can see the fire on the clothing, and you can see molten chunks being thrown significant distances both behind the mannequin and down at his feet. By the time the firefighter is able to enter the picture and turn the mannequin for our camera, there's very little of the garment even left. It is almost entirely consumed in just those few seconds. Leave you with one last look at the consequences of wearing fuel into an arc flash.
Certainly not something I would want to be exposed to, especially if I didn't even know that that was there, if that was a potential. Okay, so question for you, another poll. Have you ever been in or seen an arc flash firsthand? And I mean yourself personally. Yes, no, or maybe you know someone who has. I don't mean a video, obviously we all just watched a video. But as you're answering, yes, no, or maybe it's someone you know, and submit that response. I've got a couple questions here, or one question here. If nothing has changed, do you still need to update the arc flash study every 5 years? And the question, I mean, the simple answer is yes. You have to have your arc flash study at least reviewed for accuracy at intervals not to exceed 5 years. If nothing has changed, great. You had your review. You don't have to necessarily change the labels out. However, that is something that we need to look at with this new NEC version verbiage. It says that it needs the date that the assessment was completed. Depending on how auditors or safety professionals or your own safety program interprets the use of that, there could be a justification for replacing the labels even if nothing changed. Although, as it stands today, and as the 70E is written, which the National Electrical Code points to the 70E, remember? It just says reviewed for accuracy, and if there's a change, replace the labels, update the labels. So, long story short, yes, every 5 years, you're gonna need to at least review that study and all its details, and then update anything that has changed. All right, I'm gonna go ahead and close the poll out and share the results here. And the majority of you said no, but actually 29, yeah, almost 30% of people have actually been in or seen an arc flash firsthand. I still like to point this out, and I appreciate everyone's participation there. It's not rare. I mean, look at this. Even just from our group, almost 30% of us have actually seen one or been in one themselves firsthand. It's not rare. It is relevant. It is prevalent in many, many industries. Awesome. Okay. Unfortunately, if you're in an arc flash unprepared, it could lead to months on end trying to recover. Agonizing time in the hospital, frankly humiliating things as far as trying to recover from that and being completely reliant on everybody else for everything for a while, as well as the pain of it and the psychological side of things. Nobody should have to go through this, and there are ways to predict the severity of arc flash events and protect it accordingly. So this, in my book, in today's world, is inexcusable. We have ways to do it. There are enough options, service providers or education for you to do it yourself, that you should not be leaving people exposed to this kind of future potential. So let's look at some of these arc flash labeling solutions. Well, what it boils down to is getting an analysis performed. It's typically an engineering study, so you collect the data, however makes sense for you. We prefer to go on site and collect what's physically there, not just what the drawings say, because what if those are outdated? So we go get that data, we put it into our engineering system, the SKM Power Tools or Easy Power or ETAP or whatever it is that needs to be used to calculate that. Have a review, make sure everything works correctly, looks right, prepare those labels, and they're good, durable labels to withstand the environment and be, holding up for the duration that needs to be there, minimum 5 years, right? Then apply those labels at each electrical enclosure that has any potential for an arc flash, and then sign off on that study. So those labels, creating the labels, there are several different layouts that you might see out there. So this is just an example of what our labels might look like. Most arc flash labels will have an orange top with black lettering warning. Maybe it'll say qualified persons only, and that is usually for things less than 40 cals per centimeter squared. And then if it's over 40 cals per centimeter squared, a lot of times you see it change to a red top with white letters that says danger. And that's, again, usually because people don't have stuff rated greater than 40 cals. So you get that 40 cal suit, and anything above that requires somebody else who has higher rated equipment and or additional risk control methods to remove them from those hazardous areas. So there's a lot of information that can and should be included on your labels. Minimum, how you're going to protect yourself, that incident energy exposure level, the PPE required for that hazard, somehow, some way protect yourself or know how to identify the PPE needed, the voltage information, and your boundaries. So all of that's included. You need to be able to read through those and train on them appropriately with anyone who should implement that information. Having the labels, even for equipment that's less than 1.2 cals per centimeter squared, prevents a lot of this idea of no label, no PPE needed. Well, that's not necessarily true. I would say the minimum amount of PPE is needed if it's less than 1.2 cals per centimeter squared. I see some safety programs where they just say they only label equipment if the hazard is calculated 1.2 and above. Well, then again, what about those pieces of equipment that are only 0.01 calories per centimeter squared? Arguably, there's not an arc flash hazard, quote unquote, there, right? But there's still shock hazard potential anytime it's exposed and energized. So that's not no PPE, it's just maybe not arc flash PPE. So I would say go ahead and calculate it all out and put the labels on just to be certain. No guesswork, no assumptions. They know, is it a hazardous level that requires PPE or not? And even the lower arc flash hazard levels, we still highly recommend arc rated shirts, even better if it's a uniform or coveralls, safety glasses, hearing protection, and of course you need your gloves and your boots, because even at these so-called quote unquote low arc flash hazards, there is still a potential for up to first, second degree burns. There's the potential for molten material flinging out, like molten copper, which is about 1900 degrees Fahrenheit, and non-rated 100% cotton shirts can ignite at less than 800 degrees. So you do the math. I would still recommend wearing, if nothing else, an arc-rated shirt and your shock protection. So there's some nuance there, but then once you get to that 1.2 calorie per centimeter squared threshold and above, there is no guesswork. There are bare minimum requirements, such as arc-rated shirt and pants or arc-rated coveralls to the minimum calorie per centimeter squared rating that they're exposed to, the face shield, arc-rated balaclava, safety glasses, hearing protection, both sets of gloves, and your boots. That's typically also called Cat 1, Cat 2, just from the PPE suppliers. If you do the incident energy analysis method, for us, we mirror what PPE suppliers market their stuff as. So you might see a 1 or a 2 on the label, just to make it a quick reference to what your workers are actually wearing. Same idea for levels 3 and 4. So a lot of times people know I go grab my Cat 4 suit because that's what it's labeled as. So it's a 40 cal suit, jacket, and pants or coveralls with the arc flash suit hood, beekeeper style or lift front, safety glasses, hearing protection, both sets of gloves, and your boots. Now again, specifying this information on your labels takes out the guesswork, takes out any assumptions. And then again, above 40 cals, you might see no adequate PPE or no PPE defined because your site just simply doesn't have PPE rated higher than this. Could be above 60. We've seen that before whenever everyone has a 60 cal suit available rather than just a 40 cal suit. Whatever makes sense for your safety program and the qualification level of your workers. So again, that's a usually designation. Where should these labels be located? Anything likely to require examination, adjustment, servicing, or maintenance while energized. That's what it is. That's what's required. So your panel boards and your disconnect switches, this includes control cabinets that have three-phase distribution inside of it. So that three-phase breaker or fuse disconnect switch in the same cabinet as your controls. Well, now that so-called control cabinet has a potential for arc flash hazard as well as that shock potential. So include that in the study, get that labeled as well. Switchgear and switchboards, the different sections, a lot of times they'll have each section having its own label. Motor control centers really only need one label, but we like to put multiple just to make it easy to find. They're all gonna say the same thing because the incoming power is what it's based off of, the highest hazard in that enclosure. Overhead bus ducts, again, three-phase, gonna have some hazards there. We see some people try to label each of the buckets, but really it's all across gonna be the same because again, it's all gonna be on that line side is the higher hazard vast majority of the time. So we put larger labels that you can read some information from the ground and we put them all along every 3 sections. So you're never more than 15 feet from a label. It's not going to be an Easter egg hunt situation while you're trying to find your safety protocols. And you can read some of the information from the ground because it's a larger label. Not necessarily required to do it this way, but this is a best practice. So the key steps for your arc flash: labeling to avoid missing that information. Perform a full engineering analysis. Don't stop just because you think, oh, well, below this point, there's no way it's going to be a higher hazard level. You'd be surprised. Long runs or right after another transformer, it could increase the arc flash hazard, even if it's been less than 1.2 for a little ways down in the system. So don't assume anything. Do a full engineering analysis. Apply easy to read, durable labels. It does need to be able to withstand the environment that it's in, not just, paper and packing tape. I've seen all kinds of things. And train your qualified people on how to read the labels and use the information, not just read it. If you need some help, of course, we are able to do that. That's kind of our bread and butter here at Herzig Engineering. Our arc flash study has been doing it for 25 plus years, all over the country, and several international projects as well. And for every training or every study, you get training. That's going to be typically a 4-hour training. And in the meantime, if you would like to just have a summary, a toolbox talk to talk about arc flash label and PPE use for your workers, there's a free training that we've put together, herzigengineering.com/labels. Nice little less than 15-minute toolbox talk over these topics. Great refresher. It is not a complete and compliant training. There's, of course, all the risk assessments and job safety plans and establishing electrically safe work conditions and energized work permits, and there's all kinds of other things that you need to train over as well, but this is better than nothing to get you stepping in the right direction. All right, and with that, I'm going to open it up for some Q&A. I do see a couple questions in the question feature or the chat box. Please feel free to submit those now. I will note that if you have to jump off here, no worries. You are more than welcome to reach out to me at any time. You can email me, my email's right there. You can download the handout and you'll always have my contact information through that. Or you can go to herzigengineering.com. There's a lot of ways we can get in contact through that. Or you can just call the office and ask for Caitlyn. I'm the only Caitlyn here, so they will know who to send you to. If you need anything, always feel free to reach out. Otherwise, thank you so much for your time today, guys, and I will dive into some questions here. So, if a contractor had done the install of new equipment and building, are they required to do a study? So, are they required to do the study? Is the contractor required? I would say no, but you should be including that in your contracts now, that once it's installed, it needs to have that label, and the owner of the equipment is the one responsible for getting that study done technically, like, the buck stops with them, but it only makes sense if it's a new install that you include that as part of your contract, if at all possible. There's a question about the NFPA 70E exam. I assume this is talking about the Certified Electrical Safety Compliance Professional certification, about which edition. And right now, I believe that they have the 2024 edition as the NFPA 70E tested book, I believe. Surely they've updated it to that by now, but I'm blanking. And then the 2026, that call out is for the National Electrical Code, rather than the Standard for Electrical Safety in the Workplace. And if you have more questions about that, feel free to reach out. All right, any other questions? I'm looking through, and there's a few that I had already answered in the content. So if there's not any more, then we will be great. All right, got a couple more. As the owner, am I required to have this done with contractors going lotto? Okay, so yes, if you own the equipment and you're having contractors come on site, the contractors need that information as well. So yeah, having arc flash study done for the contractor's safety is going to be required, even for performing lockout tagout, because the point there being it's live until you verify that it's not. So through the process of establishing an electrically safe work condition, you have to verify absence of voltage with your meter, which means exposure to those electrical hazards potentially. So PPE is required, boundaries required, the whole 9 yards. So yeah, even just to perform lotto for electrical equipment, if you're exposing yourself to those conductors or circuit parts, you're going to need that study in order to keep everyone safe. Get those labels done. Would one be on file somewhere to see in the past? As far as new installation, I'm sorry, Patrick, I'm trying to go back and look at your previous question here. They might have done some equipment evaluation or analysis, but if they did not give you that report, then probably not. It's always worth asking and reaching out to see if that was part of the scope of work that you had whenever you had new equipment installed. But if they didn't already provide that, I would imagine not. Fred's asking, do we know the temperature and pressure of the blast and the duration? That all comes from the results of your study. So the temperature of an arc flash can be thousands or even tens of thousands of degrees, but it's measured in calories per centimeter squared. So this is the amount of thermal energy impressed on a surface a certain distance from the source, called the working distance, generated during that electric arc event. And that working distance is usually 18 inches. And I think I just basically gave you the definition of incident energy, so I'm not so sure how helpful that is, but essentially it's going to look at how long that arc occurs, so how fast can the device operate. So the duration is a big factor to determine how severe the arc flash will become. The longer it sustains, the hotter, the more severe it would be. The pressure waves of an arc blast are dependent on some other factors, like the amount of capacitance in the system. So after large transformers, or if there's really large capacitance in the system, medium and high voltage stuff are more likely to have this. Could be a pressure wave blowing you across the room, blowing parts of the equipment apart, being even higher, potentially hazardous than the arc flash itself. So there's a lot of different things that go on in that. The blast pressure waves are the most difficult to estimate, but the duration and the temperature are very specific results of an arc flash study that you would get. Is there a phase in timeline for the date requirement on the labels? Will we need to replace the labels every 5 years? That is a fantastic question. As it stands right now, it does not seem that the labels have to be replaced every 5 years, but you do have to have the study reviewed and updated every 5 years, and the industry best practice is to go ahead and replace the labels just for clarity on when that study was last reviewed. If there are 11,000 volt switch gears and all panel doors are closed, will they affect persons near it? Possibly. So it depends on how they're interacting with it. Are they turning it off and on? Are they replacing any components? Have there been any issues with it previously? What is the condition of that equipment? How long ago was it last serviced or maintained, if at all? All of that goes into your risk assessment to determine if arc flash and even electric shock protocols are necessary to be in the room. Sometimes, depending on the situation, why you're in there, the condition of the equipment, how you're interacting with it, just walking past it, it's justified to be protected. And I know people do not like that answer, but that is the reality. You need to be protected if it's in bad condition. How long are we required to keep records of studies? That's another good question. I would say you mostly just need to keep the most recent version readily accessible, because that's going to be the one that is most relevant. I know whenever there are studies done on our end, like if we've done the analysis, we keep the previous versions just for our record keeping to make sure that if any feedback comes, or if there's any question or doubt about what changed and why, we can always go back and compare for you guys. Awesome. Great questions, everybody. I'm just circling back to make sure I didn't forget anything. And if there's any follow-up needed, if I wasn't completely clear, or if I didn't quite answer what you were meaning to ask, please feel free to rephrase your question for me. Otherwise, I really do appreciate all your time and attention today and your interaction. That always makes it go a lot better for me personally. So appreciate it. If you have anything else, once again, don't hesitate to reach out. I'm always happy to help, answer questions, or provide some guidance. I hope you guys have a great rest of your day, and I'm going to disappear into the background for a couple minutes and then close it out. Thank you.